Hello and welcome to Homework Help for Lesson 8.6. We'll be evaluating trig functions with these three problems from number 1. Before we jump into it, let's lay out some basic steps that will guide us through the entire homework. So to evaluate trig functions, especially in radians, we have this initial step. We have to convert from our radians to degrees. So the way I like to do it is Everybody should know the basic conversion that pi is equal to 180 degrees. Now from there, if I divide that in half, well, that's 180 divided by 2, I'm left with now 90 degrees. If I take 180 divided by 4, I get 45 degrees. If I divide it by 3, I'll get 60 degrees. And if I divide it by 6, 180 divided by 6, I'll get 30. And so if you are able to commit these to memory, you'll be able to do these problems really quickly. Now, it's not too hard to remember. If the pi divided by 4, it's the only one with the 4, and it's the only one with the 4 in the degrees as well. Pi over 4 is 45 degrees. And then as for these two at the bottom, it's kind of like the opposite of what you think. When pi is divided by 3, you actually get 60. And when pi is divided by 6, you get 30. So it's kind of like you see a 6, but you end up with 30. You see a 3, but you end up with 60. It's just remember that it's like the opposite of what it looks like. So let me show you why this can be so helpful. If I say 5 pi over 6, for example, well, we can very quickly calculate this if we remember that pi over 6 is actually equal to 30 degrees. Well, I'm going to rewrite this first. This is equivalent to 5 times pi over 6, right? If I put this over 1 and multiply across, I'll get 5 pi over 6. But so if you keep in mind that, hey, pi over 6 is actually 30 degrees, then you're simply doing 5 times 30, and so you get 150 degrees really quickly. If I said 4 pi over 3, so now so you need to focus on pi in the denominator. I'm given 4. This is really 4 times. And what's pi over 3? So remember, it's like the opposite of what you think. So that's actually 60 degrees. So 4 times 60 degrees is 240. I can do another one. 7 pi over 6. So pi over 6 is 30 degrees. So multiply that by 7. 7 times 30. So you can just focus on these two numbers. 7 times 3 is 21, but we have to add the 0. That's 210. For one final example, I hope you're getting the hang of this. If I have 3 pi over 2, so pi over 2, again, this is only going to work if you've actually committed these to memory, but pi over 2 is 90 degrees, so 3 times 90 is 270 degrees. So that's like how you can do these conversions relatively quickly. But let's jump back to our steps. So step 1, convert from radians to degrees. Check. Now step 2 asks you to write the formula. So for example, if you're asked for sine of 30 degrees, you should immediately write y over r, right? Because sine is asking you for the y side over the r. If I said cosine of 60 degrees, you should write x over r. That's what I mean by write the formula. Write down right away what you need. Next, in terms of x, y, and r, next, you're going to take your angle and graph it in the proper quadrant and label the reference angle. So we'll go over this in detail in our examples. And then finally, we will label the sides, but watch out because x and y can be either positive or negative, depending on what quadrant you're in. So in quadrant 1, they're both positive. In quadrant 2, x is negative, but y is positive. In quadrant 3, I have a negative x and a negative y. And then in quadrant 4, I have a positive x and a negative y. So you need to keep those in mind. And then remember, r is always positive. R is always positive. Okay. So if you've got those 4 steps written down, then today's homework will be very easy for you. Also, remember that when it comes to labeling our sides, so this is for step 4, If it's across the 30 degrees, you're going to write 1/2. If it's across the side is across 45, you'll write root 2 over 2. And finally, across the 60 degrees, we always write root 3 over 2. So these are our big three. And then, of course, r is always 1, positive 1, positive 1. Okay, so let's jump into the first problem. Problem number 1C. It says, hey, evaluate cosine of pi. So if you've written them down, then you'll remember that our first job is to convert this into degrees. So let's rewrite this. That's cosine of pi represents 180 degrees. Our second step is write the formula. So that's going to be x over r. I know that because that's what cosine's formula is. Next, the third step is, hey, graph your angle in the proper quadrant. So 180 degrees, you should know that this is 0. Up here is 90. I don't really like to write it though. I like to always write the 0 and the 180. So 180 is directly to the left, and 180 is over here. So we can't really create a triangle, but see if this comes back to you from previous lessons. When we're on the axis, it's called an axis angle, so that's for 0 degrees, 90 degrees, 180 degrees, 270, 360. Right, we're on the axis. We just draw a point. We set r equal to 1. R would be this distance right here. And then we have to label that point as an x and a y. So keep in mind, I'm moving 1 unit to the left. So that means that my x should be a -1. And since I'm on the axis, I'm not above it, I'm not below it, that my y should be 0. If I had asked you for 90 degrees though, then you would set r equal to 1, but your x would be 0, your y would be +1 because I need to go up 1 unit. I hope that makes sense. And then down here it would be 0, -1, xy. And if I asked you for 360, that would be 1, 0. So these are our points for all the axes. But coming back, we've labeled x, we've labeled y, we've labeled r. So we've already finished step 4, which is, hey, label the sides. In this case, it's just a point. And now, well, we're basically done. I know my x is -1, so I can plug that in right here. That's -1 over, and my r is 1. So cosine of 180 degrees is -1 divided by 1, which is just my answer of -1. Okay, let's do problem number 1D. This is a more typical problem. I started us off with a kind of funky one that will lay on the axis. Now let's do a more normal looking problem. So cosine of 5 pi over 3. So first step, convert to degrees. I see I have a pi over 3, which is 60. So I'm going to be doing basically 5 times 60, which is 300. So I'm going to rewrite this as cosine of 300 degrees. Next step, write the formula. So this is going to be, again, x over r. That's my cosine formula. And now we have to graph it in the proper quadrant. So 300 degrees lies, if this is 180, and this is 0, but also it's 360, 300 degrees is going to lie in quadrant 4. Okay, since we're in this quadrant, we have to drop the perpendicular to the x-axis. And now we have to label our reference angle. So your reference angle is always this central angle inside your triangle. And the definition of a reference angle is how far in degrees your angle is from the nearest x-axis. So in this case, my nearest x-axis is this one right here. The other option, if I was in this quadrant or this quadrant, I would be using this axis. I would be using 180 degrees as my measure. But since I'm on the right side, I'm going to use this axis, which represents 360 degrees. Now, here's why I need to use that. Because if I'm trying to find this distance, and I know this is 300 degrees, right? This line is 300. Well, from here to there, that's 300 degrees. but this entire distance around is 360. So I'm actually interested in doing the bigger angle, which is 360, minus the smaller angle, which is 300. And if I do that subtraction, my answer, 60 degrees, that'll be the difference, the leftover between them. And that's exactly what we need to find, is that reference angle. So by doing our subtraction, we realize that our reference angle is actually 60 degrees. I'm going to clean this up a little bit. So my reference angle here is 60 degrees. And that makes sense because 300 is 60 degrees away from 360. So if that's 60 degrees, then this one right here must be 30. This is a 30, 60, 90 triangle. So now we can label our sides. We're on step 4. So across from the 60, or I can start with my radius, okay? My r, my hypotenuse, is always 1. Let's label it. R equals 1. Next, across from the 60 degrees, that's going to be root 3 over 2. But careful, since I'm going down, I'm going to label that negative. This is a negative y. And then across from the 30 degrees, that's this side right here, it gets a 1/2. And since it's to the right, that's going to be a positive x value. So I'm going to go ahead and label this. That's my x, and that is my y. So we're almost finished. We've drawn everything we need. Now we just need to find, we've labeled all the sides, so now we just need to pull from the information that we've drawn out. What is x? Well, according to our drawing, x is 1/2. Lastly, we have to divide that by r. And what's r? R is just 1. Well, hey, anytime you divide something by 1, you can really just ignore the divided by 1. The answer is just itself. 1/2 over 1 is just 1/2. And that's our answer. Cosine of 300 degrees equals 1/2. So there's a lot going on, but the steps are the same and they do not change. So we have that going for us, just the consistency. Let's do this last example. You can see that we've done, we're going to be doing 3 types of problems here. We started with an axis angle problem, and then we did like a conventional 30, 60, 90 triangle problem. And now we're going to do a negative angle problem. So the same rules apply for our negative angle. Step 1, we're going to convert into degrees. So this is sine. We're going to hold the negative, right? It's negative, and now we have to figure out what that is. Well, pi over 6 is 30. So I'm really doing 5 times 30 degrees, which is 150. So this is sine of negative 150 degrees. Next step, write your formula. That's equal to y over r. And now we have to draw this. We have to draw 150 degree, negative 150. So the mistake a lot of people make at this point is they just draw regular 150 degrees. So positive 150 degrees would take me like right around here, right? You're not quite at 180. You're actually 30 degrees away. How did I know that? Well, because if this is 150 and this is 180, I can do, again, big angle minus small angle. 180 minus 150 leaves me with the difference right here of 30 degrees. So a lot of people will, a lot of students will make the mistake of just carelessly drawing positive 150 degrees, when what they really should be drawing is the flipped image of that. If 150 degrees takes me here, then negative 150 degrees will take me exactly right here. So the way I like to teach graphing negative angles is, hey, first draw the, for example, if I said negative 45 degrees, first draw the positive version as a dotted line, label your reference angle, and then flip it over the x-axis. So you were always flipping up and down. We're never ever flipping left and right. This would be incorrect. That right there is not negative 45 degrees. You flipped it to the left. We need to flip it up and down. So that would be, if that's positive 45, then negative 45 goes the other direction. And that would be correct. So yeah, negative angles are not scary. Just start with your dotted line and then flip it. Now keep in mind that the reference angle will always be the same. So if that was 30, this is 30. And now we can drop our perpendicular and label our sides. I'm going to clean this up a little bit. Okay, so across the 30 degrees, we should get a 1/2. If that's 30, that means this has to be 60, and across from 60, we get root 3 over 2, and r is always 1. This is my x, this is my y. Now, before I go any further, I do want to say I've made some critical errors, and it's going to affect my answer. See if you can find out the mistake that I made. So, the mistake has to do with the fact that I'm in quadrant 3, and when I'm in quadrant 3, you should know that x must be negative and y also must be negative. That, after all, is the only way I'm going to go to the left and down and end up in this quadrant. So I need a negative in front of my root 3 over 2 and a negative in front of my 1/2. Now I've correctly labeled x, y, and r, and I can just pull from that information to substitute for y. Instead of y, I'm going to write negative 1/2. And then instead of r, we're writing 1. And hey, we just went over this. Anything divided by 1 is just itself. So the answer is negative 1/2. Okay, I hope you found that helpful. I will see you next time. Look how pretty that is. We did good work.